All right, thanks everyone for joining us here today. My name's Shane Murray. I'm the head of AI research and strategy at Monte Carlo, and with me is Bryce Hetzel. Bryce is one of our product leaders, leading a lot of the development of AI products within our software. I'm excited to be here to join you all today, and thanks for coming to this session. Maybe just a quick note, Databricks have been a great partner to us and to many of our customers here, so big shout out to Databricks, and thank you for just naming us the Data Governance Partner of the Year. So cheers for that to our friends at Databricks. So we're going to cover 3 topics in pretty quick order here in 15 minutes or so. The first is what I've called the illusion of done. Then we've got Bryce is going to walk through some lessons in building impactful AI. And then finally we'll end with some musings on operationalizing trust and reliability in AI products. Okay, so let's maybe start with the launch day. And I'll put this through the perspective of conversations I've had both internally with our teams, but also with many customers, dozens of customers who are building AI in production. Often, maybe as opposed to traditional software engineer or even machine learning, the actual POC is kind of the easier bit. And actually, once you get into production is when you have to really figure out how reliable your data is, and whether you can actually scale this out to many users in a reliable way. And so, in a way, the development cycle has shifted, and a lot of the work to ensure this reliability happens in production. Some of the reasons for that, one is that these inputs are much less predictable. You have unstructured data, you have knowledge bases that are changing constantly and that are providing inputs that are a lot harder to measure and monitor. The second is that your outputs from AI non-deterministic. And so, you couldn't exactly apply the same deterministic unit tests, the same guarantees on a production product. You actually need to account for the massive variability in probabilistic outcomes. And then the third thing is that small changes in this system, small changes in the data, the system, the code, or the model can result in very drastic and maybe cascading failures in the AI in production. And so these are some of the challenges that teams I talk to are really struggling with as they try to scale from POC out to a production AI use case. So what do we do about that? I think one thing we're seeing people succeed in, and both this is our teams internally at Monte Carlo that Bryce will speak about, but also our customers, is taking a very pragmatic approach to these problems. And that really starts with focusing on deep business pains. This has probably been true for machine learning as well. You want to actually recognize what are the problems that I'm going to be solving in the product for the next 1, 2, 3 years. Not what are the most immediate problems, but what are the long-term user needs to solve for. The second is, I think where teams are succeeding is doubling down on Gen AI strengths. So this may or may not be a chatbot. Chatbots have definitely got the most, I'd say, sort of public announcements around both customer-facing and internal chatbots, but a lot of teams are having gains in this space by handling topics like summarization, taking unstructured data that was previously structured by humans, and instead transitioning to a kind of human review process, and then tackling sort of process automation within the business. Things that have been done time and time again and can be automated and scaled up. So I'll pause there. I'm going to hand over to Bryce, who will talk a bit about how we've tackled these types of problems at Monte Carlo, and in particular around a use case that we call the troubleshooting agent. Bryce?
All right, thanks, Shane. Yeah, so Shane has, if you get a chance to talk to Shane, I would. He's a treasure trove of talking to so many of our customers about the initiatives that they're taking on around AI today. but I want to kind of pivot over, as he mentioned, to how we're using it internally, and a project that we've been working on and getting to production, and how our problems are just starting now that we're in production, right? And I think the first three things here are kind of your traditional product management problems, right? Or approaches, if you will. Nail down that valuable problem, right? What is the user problem here that we need to start with? And how can we make sure that we're solving something that has a lot of pain around it, and is aligned to generally the products that we've already have in place, right? If we want to have those synergies, we want to leverage the core competencies that we have, and that's kind of been our approach. Is we had all this existing access and collection of customers' metadata and logs and lineage about their data platform in Databricks, right? And we could sample it from there. We have rich historical incident data. And so if we could take those things and work towards solving for that pain, where they have lots of costly incidents that come from the data platform, and a lot of times have this kind of executive visibility, if we can help kind of reduce that time to resolution, we felt like that would be a good problem to go tackle for customers today. And lastly, I would say kind of where it branches off your more traditional software project is that kind of fit for AI, right? For us, getting into troubleshooting the data estate really we found it to be clear, repeatable questions that people were asking, kind of flow charts, if you will, of things you were checking, like data. Was it a system failure? Was there a code change? And now maybe is the model output changing from what we might expect, right? So how do we kind of take that problem statement and move it towards reality, right? Well, we pushed quickly towards a prototype, right? We wanted to figure out, can we get this in front of customers and prove out that value as quickly as possible? And I think there's a couple points in here that kind of really show how seriously we took kind of getting to the customer value first and validating that, like thinking about what can we build on a short timeline, realizing that text isn't the best UI, but it's really hard to validate on demo data when you're kind of just going through a wall of text, right? Anybody can just read that text, and if it's more applicable to your data, that's the best way we can help kind of validate that with customers. So we were taking approaches of kind of taking those production problems, like things like big infrastructure, and moving those things aside until we got that validation of the problem. Even to the point of just sharing kind of some of the outputs in Google Docs and getting on the phone with customers and talking through those problems, right, and the outputs we saw there, and hoping we could get that right validation that this was the most important problem we could be solving for them, and that it looked valuable out of the gate. And when you get those moments of people kind of falling out of their chair, seeing how that actually kind of accelerated and looks correct on like the first try, it's very exciting, and you have something maybe interesting. So how did we build this out and iterate on from there, right? Even before kind of building out the infrastructure side, we work towards a prototype where you start to think about kind of that top layer of, we have alert data, we spawn a troubleshooting agent, and then maybe we want to aggregate findings and reason through them and post them out, right? Well, the iteration we actually took even before focusing on the infrastructure and some of the data pieces was, can we actually kind of make that output much stronger? So we spawn multiple agents that are specialized instead of just doing one kind of summary. As you can imagine, these AI agents actually can be kind of like me or us, and we lose track of what's going on if we have too much information thrown at us at once. So if we're troubleshooting a data issue, we have to think about the data underlying itself, maybe metrics around it, or the analyst agent going to look at specific fields, queries, job, and code, like I mentioned earlier. And then we have other even sub-agents from there that can go reason through each PR that's been merged and each job that's run and so forth, right? So just to kind of pivot, just to show you kind of the reality of it, right? We did kind of build this into production, even just behind some kind of infrastructure constraints, but we have this alert. So this is a table in the data, the lake house, where we see a large drop in data volume, right? And so that's just core Monte Carlo. We're doing an anomaly detection to alert you when a few tables here have all seen a big drop in data. And then we're actually kind of running the agent then to actually start to just go troubleshoot this in real time. And so we're gonna basically, let me I just refresh here. Let's see if we lost the internet access, but give it one more whirl. does look like we're gonna lose access to the internet there. So I'm gonna pivot back to my GIF for a second, and we'll maybe come back and see if it runs itself. But you can kind of see here live that we're reasoning through, and you see some of those subagents. It's a little hard to tell, I know, but we're collecting all those pull requests and that information there. We're collecting query changes, and that's core data that we've been building with Monte Carlo and solving customer problems for a long time, right? And then we're kind of serving that all up and starting to summarize it through. So you can kind of see that, and maybe that's some of the output there of funding some of those infrastructure issues. So you get to see that, but I think it's actually the Wi-Fi. But just to kind of summarize, I think getting towards that kind of demo and getting towards putting it in front of customers with their data was a really strong approach for us. And then now we're kind of working towards those data quality pieces to make sure that data we're serving to it is something that really we can iterate on and get stronger and make sure, because we know it's going to shine a flashlight on some of those data issues that we might have in the product overall. So I'm going to pass it back over to Shane to kind of talk through validating that out.
Yeah, so I think one thing that Bryce and the team have learned internally, but also a lesson we've learned from many customers who are building similarly, is this is going to be a combination of human and machine validation in production. And so this is kind of roughly how we're thinking of evaluating the quality and reliability of the outputs of this application. You can think of at the highest level, you want to ensure that this feature is giving helpful responses that can guide, engineers in their process, and that is more than just kind of a trivial output for them, I'd say, but also that it's actually helping them to practically reduce the time to resolve an incident. So you can think of that as the highest level goal here. And then there's a couple of ways we're looking at how we'll evaluate the performance in production. One of them is actually having experts, having engineers validate some of these outputs. So would this explanation help me find the real issue faster? Is this causal reasoning sound given what we know about our systems? Are there obvious missing pieces or red herrings that we might look at? So that's kind of a human element that can be the human in the loop on this agent. And then below you can actually complement that with some LLM as a judge type metrics. And here we're looking at things like, what is the causal accuracy of what we're producing? Does it actually, take its evidence and apply that causally in the right way? Second, contextual completeness. Is it bringing all the information together that we'd expect to inform this outcome? Third is the quality of the evidence. Is it able to cite particular data and bring that to bear in the response? And then finally, actionability. Does it actually give the engineer some next steps to take in order to actually resolve this incident? So there's quite a few layers to output validation, in addition to some of the monitoring we'll have on the sort of inputs and the systems that are feeding this approach. And so maybe I'll just wrap up with some musings, I guess, or thoughts on how to stay ahead in this space. The lessons we've learned. One of them is the fastest way to AI-ready data is to really start building something and learn where your gaps are in this sort of bias of the data, the quality of the data, the lack of reliability. The best way to do that is to start with a proof of concept, put it in the hands of users, and start learning. The second is this rule I've mentioned, just prioritize human-in-the-loop systems. It doesn't have to be an autonomous agent. It can have quality gates, and it should have quality gates and continuous feedback from humans in the approach. The third is this idea of evaluating the required level of accuracy or quality required in this solution. In some cases, hallucination could be a feature. In other cases, it's a bug. And so actually kind of calibrating with your user base around the right level of quality is critical for these applications. And then finally, making sure you have observability across that end-to-end data and AI landscape. So thank you everyone for your time today. Appreciate the patience as we got started and hearing us on this talk. And you can head over to Monte Carlo past the helicopter for some demos and some booth merch. We'll be there all day. Thank you.